this video, we're going to look at how to find the greatest common factor. To find the greatest common factor, or the GCF, we could use a chart. So the first example says to find the GCF of 8 and 12. So I'm going to write 8 and 12 on the top of each of my charts, because those are the values I'm working with. The factors are numbers that multiply to the original number. So to find factors, we're going to divide the number out. And we only want to use whole numbers. So the one factor that always is true is 1. 1 is a factor of every number. So 1 times 8 gives me 8. So I'm going to write those together in the chart. And so the next number after 1 would be 2. 8 divided by 2 is 4. So I could also say 2 times 4 equals 8. After 2, obviously the next number would be 3, but 3 does not go into 8. So those would be all my factors of 8. I'll just stop there. And I chose to stop there because after 3 is 4, and I have 4 on my chart right here already. So now I'm just going back the other way through the numbers. Now we'll move over and we'll do 12. Again, 1 always goes into any number. It's just 1 in the number. So 1 and 12. 12 divided by 2, that's 6. So 2 times 6. 12 divided by 3 is 4. So 3 times 4 equals 12. And then I go back to 4, and now I'm just going to be going up this side of the chart here. So I found all the factors. Once you find the factors of each number, you want to find the largest number they have in common. So identify all the numbers they have in common. 1, 2, and 4 are in both of my charts. So the largest one would be 4. So the GCF of 8 and 12 is 4. Let's do another example. We could also find the GCF using a list, and I'll show you how that might look. So our second example is find the GCF of 16 and 30. Again, 1 still goes into every number, so 1 and 16. Now I'm going to write them on the ends. Okay. Now as I move in, I'll put them on the inside. So 16 divided by 2 is 8, so 2 and 8. 16 divided by 3, 3 does not go into 16, a whole number. And then we have 16 divided by 4, which is actually just 4. So I'm going to write him in there like that. So those would be the factors of 16. Do the same thing with 30. 1 and 30. 2 goes into 30. 2 times 15. 3 also goes into 30. 3 times 10. 4 does not go into 30. And then we have 5 and 6. And you can see on the list there, 5 and 6 are consecutive integers. So now I'm just going back through my list, so I know I've reached the end of my factors. Again, we want to find the GCF, so find all the factors they have in common. In this case, it's 1 and 2. So the greatest common factor would be 2. Greatest common factor, 2. Now we could also be asked to find the GCF of negative numbers. The example would be negative 50 and 60. And I'll kind of switch between the chart and the lists. I'm just going to use the lists for this one. If you have a negative, like negative 50, just write the negative 1 first. Now treat the number as if he was a positive. Okay. So start with 1 and 50. 50 divided by 2 is 25. 3 does not go into 50, neither does 4. But 5 goes into 50, and it's 5 times 10. 6 does not go into 50, 7 does not, 8 or 9 do not go into 50. So that would be our list of factors. Now let's do 60. As always, 1 and 60. 2 times 30 is 60. 3 times 20. 4 also goes into 60. 4 times 15. 5 goes into 60. 5 times 12. I'm running out of space here. It's okay. And 6 goes into 60. 6 times 10. 7, 8, and 9 do not go into 60. And I'll show you that here with a calculator. So here's my calculator. Let me turn it on. So I have 60, and I want to check if 7 goes into it. So I'm going to do 60 divide by 7. That's 8.57 rounded. And that's not a whole number. 60 divided by 8. 7.5. That's also not a whole number. And 60 divided by 9. 6.67. So that's how you can use a calculator to help you on finding your factors. The numbers we've been using in our examples, you should be familiar with enough to be able to do these. But if you come across some and you're not sure if a number goes into it, just use your calculator. That's okay. So if we go back to our example of negative 50 and 60, we see they share the factors of 1, 2, 5, and 10. So the greatest common factor of negative 50 and positive 60 would be 10. Now this unit's all about polynomials, which has variables. So what do we do when we have variables? X squared and x6. We want to know what's the GCF. We're just going to use our exponent rules. So we know that x squared expands to x times x. And x to the 6 is x times x times x 6 times. And now we're going to see how many do they have in common. So this one has 2 x's. X to the 6 also has 2. So their GCF would be x, or in other words, x squared. All we want to know is how many x's do both of them have. Let's look at another one. So I'll do this with the charts this time. So I'll draw my charts out here. So one value is 4y squared, and the other one is 2y cubed. When you have a monomial with a coefficient and a variable, do them separately. So first I'm going to look at the coefficients. The factors of 4 would be 1 and 4 and 2 times 2. Now do your other coefficient. The factors are 2, or just 1 and 2. What's the GCF of these? I can see that they both have a 1 and 2 in their tables, which means that their GCF would be 2. Then move to the variables. Again, we're going to take our y squared and 4y squared, and we're going to expand them out. So y and y. And we'll do the same thing with the y cubed and 2y cubed. Y, y, y. How many do both of these have? Well, I can see that this one has 2, and this one also has 2. So the GCF would have a y, y, or in other words, the overall GCF would be 2y squared. Let's do one more. So this example has negative 16 t to the 5th and 30 t squared. I'll use the charts again for this one. Negative 16. Take out the negative one first. Now treat him like he's positive. So I have 1 and 16. 16 divided by 2 is 8. So 2 and 8. 3 does not divide into 16 evenly, but 4 does. 4 and 4. Now we'll go look at 30. as always, 1 and 30. 30 divided by 2 is 15. 30 divided by 3 is 10. 30 cannot be divided by 4 evenly. And then 30 divided by 5 is 6. Extend my chart there. Now find all the numbers they have in common. 1, 2. 1 and 2. So the GCF of the coefficients would be 2. Now go to your variables. T, 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 T gives me t to the 5th, and t gives me t squared. Or t to the 5th has 5 t's, but t squared only has 2. So they would share 2 t's in common. So t, or in other words, 2t squared would be the GCF of negative 16t to the 5th and 30t squared. This leads us into finding the GCF of polynomials. If I have a polynomial, 5c to the 5th plus 10c cubed, I'm just going to do this by each term. So the first term is 5c to the 5th, and the second term is 10c cubed. The coefficient would be 5, and factors of 5 are just 1 and 5. Then do 10. Factors of 10 are 1 and 10, and 2 and 5. Find the factors they have in common, in this case 1 and 5. So the GCF of the coefficients is 5. And now we're going to do the variables. So c to the 5th is c, 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 and c cubed would have 3 c's. I can see here when they're lined up this way that 3 of them match. So my GCF would have 3 c's in it. In other words, the GCF of this polynomial would be 5c cubed. One last example. Oftentimes, your polynomials will have more than 2 terms. If there's more than 2 terms, we're going to do the same process. Separate your terms out. So in this example, 4a cubed minus 2a squared minus 6a. First term is 4a cubed. My second term is negative 2a squared. And my last term is negative 6a. Go through and find the factors of the coefficients. 4 is 1 and 4, and then 2. Negative 2 has that negative 1, 1, and 2. And negative 6 is negative 1, and then 1 and 6, and 2, and 3. When I look at these lists, I see the largest value that they all share is the 2. So the GCF of this polynomial would have a 2. Now go to your variables. A cubed is just 3 a's. A squared is 2, and a is 1. You can see they all share a single a. Each one has 1 a in it. So my GCF would have 1a. The GCF of this polynomial then is just 2a. So a few things just to remember, summarize it up. When you're finding the GCF in numbers, you just want to find all the factors or what numbers multiply to that original value. And when you're working with variables, expand the variable based on the exponent. Use those exponent rules. That's all there is to finding GCF.